Andrej Karpathy, one of the most respected minds in AI, just did something nobody else had the audacity to do. He scraped 342 real occupations from the Bureau of Labor Statistics, fed them into a large language model with a structured scoring rubric, and ranked every single one by AI displacement risk. This isn't a think piece or a prediction. It's a scored dataset you can explore yourself. Karpathy's scoring signal comes down to two questions. Is your work product a digital artifact, and could you do this job from a home office? If both answers are yes, your exposure score climbs fast. This isn't an arbitrary framework. It's actually a proxy for how easily a task can be represented as tokens, processed by a model, and returned as a clean output. The physical world creates a natural moat that silicon hasn't crossed yet. An 8 or 9 out of 10 sounds terrifying until you understand what the score actually measures. It measures how much of the current task description can be replicated by an AI system, not whether the job itself vanishes. Software development scored this high because writing code, debugging, and documentation are all deeply digital workflows. But the developer who understands AI well enough to direct it, audit its outputs, and architect systems it cannot design alone is not being replaced. They're being amplified into a force multiplier. Medical transcriptionists scored a perfect 10, and that score is arguably conservative given how good speech-to-text and medical language models already are. The pattern among jobs scoring 9 to 10 is consistent. The output is a clean, well-formatted digital document with a defined structure and minimal need for judgment. Basic data entry, templated legal document preparation, and routine transcription share this profile. These aren't jobs being transformed. They're jobs being absorbed entirely into automated pipelines. At the opposite end of the spectrum, jobs requiring physical presence, manual dexterity, spatial navigation, and real-time environmental response are scoring near zero. Roofers, plumbers, janitors, electricians, these roles demand a body operating in a messy, unpredictable physical environment. Robotics is advancing, but the economics of deploying general-purpose physical robots at scale still look very different from deploying a software model. Tradespeople are sitting on a durable competitive advantage that most people in front of keyboards are not. A national average displacement score of 5.3 out of 10 means the median American job sits at moderate to high exposure. That is not a niche problem affecting a small slice of knowledge workers. It describes the center of the employment distribution. When you weight the scores by actual headcount using BLS employment data, the picture becomes even more concrete. Millions of people in mid-exposure roles are about to experience significant task-level disruption, even if their job titles survive the next decade. For years, the AI and jobs conversation has been trapped in abstraction, competing narratives with no shared ground truth. What Karpathy's project does is brutally pragmatic. It produces a numbered score for 342 specific occupations and publishes the methodology for anyone to challenge. You can disagree with individual scores, and many experts will. But the disagreement itself becomes productive because it's anchored to something concrete. That shift from vague anxiety to specific debatable data points is genuinely how good policy and career decisions get made. The deepest insight buried in this dataset is not which jobs are at risk. It's who gets to define what safe looks like going forward. The professionals who develop genuine fluency with AI systems, who can catch model errors, identify blind spots, and build workflows that combine human judgment with machine throughput, those people are not just surviving displacement. They are writing the new rubric entirely. The score on your occupation today is not fixed. It shifts with the skills you build and the decisions you make starting now.